Hi, we are now going to do a question on ISI. This is a question from ISI. So the question says that a linear regression model y is equal to alpha plus beta x plus error term. Let's try and understand what is this regression model, just a very basic thing. So, usually you're given a population regression function. This is the intercept term that you're given, plus beta x. This is the slope term, plus error term. This is the error term, okay? Usually, you have to find out the estimated values of alpha and beta, which is called alpha hat and beta hat. Once you get this alpha hat and beta hat, you find something which is known as the sample regression function, right? So, there are formulas for alpha hat and beta hat. Usually, beta hat is given by summation x minus x bar y minus y bar upon summation x minus x bar whole square. This is beta hat. And alpha hat is given by y bar minus beta hat x bar. So you find out the mean value of y's, you find out the mean value of x's, you already know what beta hat is from the above, and then you find out alpha hat. So the question says that beta hat is 0, which means this value is given to you as 0. So it says if this is 0, then what happens to r square? Is r square 0? Is r square 1? Is it between 0 and 1 or undefined? Let's write down the formula of r square. R square is given by this, right? So this is the formula of r square. It is summation x minus x bar y minus y bar upon y minus yi whole square x minus xi whole square under root whole square. Now, if I try and open this up, I would get this. How? Just check this out. So just see that this thing is getting whole square. This whole square and root gets cancelled with each other. So, I can write this as r square was given as summation x minus x bar whole y minus y bar whole square upon summation x minus x bar whole square summation y minus y bar whole square. After that, root and whole square get cancelled. This root and whole square is getting cancelled, and this is going square above. Very simple. Okay, now if I try and solve this further, then what I'm going to do is I'm going to multiply it by summation x minus x bar whole square and also divide it by summation x minus x bar whole square. Let's just do this if you want to. Once you do that, then this thing, or even if you do not want to do that, then this thing here, summation this is beta, right? So once you do this thing, multiply and divide by x minus x bar whole square, this thing together becomes this. Sorry for being that clumsy, but this entire thing becomes this. You have this one coming like this, summation x minus x bar upon y minus y bar, this thing, and remaining becomes this. But this is nothing but beta, right? This is beta hat whole square, and beta hat was 0. So, it becomes 0 into anything, which is 0. So then this is nothing but beta hat whole square into this thing, which gives you 0. There is another thing which is a simple thing to do. I mean, this is a derivation, but if you try and solve it, you would see that r square is nothing but beta xy into beta yx, right? This is when y is regressed on x. This is when x is regressed on y. You multiply the two betas and you will get this r square. So therefore, if one of them is 0, it automatically means that there is no relationship between r and y. R square tends to be 0. Okay, thank you.